Hello. All right, so we're going to finish up with energy today with force and motion, and then energy, how it transfers. Um, so I wanted to. I wanted to go over this with you, work with you on this Google slide activity, and then you'll have to go back in, open this link up yourself, and then complete what we don't finish together, okay? So anything that we do together on this Google slide, I will leave it, so then you'll just have to go back in and finish what we don't get through, okay? Just finish the blanks. All right, so open that up. And then we're going to just work through this, okay? So all about force. Drag the blue boxes into the correct category below to answer the question. So what is a force? What does a force cause? And how much mass, how does mass affect force? So the options that we have is force can cause an object to move, stop, change speed or direction, push or pull. The more a mass an object has, the greater the force to move it. Okay, so a force is a push or pull movement, okay? If you push or pull something, that is the force on it. A force can cause an object to move, stop, change direction or speed. And then mass affects it because if the more mass something has, the greater the force it's going to take to move it. So if you pick up a feather, you don't have to try as hard as if you're picking up a bowling ball. Okay. All right. On this one, brainstorm. Force is a push, pull an object. Brainstorm and write 4 additional examples below. So they've done one for you, pushing a grocery cart, and we're going to do one together. So what about throwing a basket or a bowling ball down the bowling lane? So throwing a bowling ball down the bowling alley lane. Well, if I could type, that'd help. Okay, so now come up with 4 more ideas where you, or examples for push or pulling. It can be whatever, whatever you're thinking. Okay? All right, so types of force. Each force is a box. Oh, maybe it would help if I would read. Each box is a type of force. Drag the word into the boxes that the picture shows. All right, so we have apple with an apple tree, a magnet, a person with a suitcase, an ice skate, someone with a grocery cart. All right, so gravity would be the apple falling. Gravity is a force. It's constantly pulling on us, right? Okay. This would be a magnet, magnetism. And then this would be friction. The blade on the ice skate is creating friction against the ice. This person is pulling the suitcase. This person is pushing the grocery cart. Okay. Types of force. Below are 5 types of force. Drag the name of the force to the definition. All right, so you have gravity, pull, magnetism, push, or friction. So based on the pictures we just used, I want you to put these in the right spot, okay? So just drag these where they go, just like that, okay? So I'm going to leave that one alone. All right, so now we're going to talk about motion. What is motion? How do we describe motion? And how does motion change? All right, so what is motion? Motion is, let's see. Oh, what's happening with my computer? Okay, sorry, I was trying to figure out what was wrong with my computer. All right, so motion occurs when one object goes from one position to the other. It is described by one object's direction and speed. And force is needed to change the direction of motion. Okay, so if a bowling ball is rolling, then the pins are acting like a force and they go to a different direction. All right, so vocabulary. Drag the blue boxes into the correct category. Woo, that was loud. Into the category. Okay, the change in position of an object because of a force. So that would be motion. Using energy to do work. That would be force. Pushing and pulling, again, would be force. Increases as friction decreases, that would be force as well. And then measured in speed would be motion. So when friction is like, if you think about sliding a box on a hardwood floor, it's going to go faster than if you were sliding a box on grass because the grass acts as more friction. Okay, friction is what happens when you it acts against the force. It slows down the force. And speaking of force, here we go again. Answer the questions below. The greater the force, the greater the change in motion will be. Explain the sentence using the boy in the box as an example. I want you to do this on your own. Think about it. He's pushing that box. The greater the change in motion will be, the greater the force. So what does that mean? So if he pushes that box hard, what's going to happen? If he doesn't push as hard, what's going to happen? Explain that in that box for me. Okay? The more massive. The more mass an object, the more big an object, the less effect a given force will have on an object. So if this was a small toy car, would it move an equal distance as the large car if the boy gave the same amount of force? No, it would move more. Because the bigger car takes more force to move. Because it's bigger, it has more mass. All right, unless acted on by a force, an object in motion tends to stay in motion, and objects at rest stay at rest. So without other forces, okay, so this guy the football player kicked the football. What is the ball going to do? Okay, answer that for me right here. What's that ball going to do? If there's nothing there to stop it, what's going to happen? What forces will decrease the ball's motion? So what could happen to stop that ball? Okay, answer those two questions for me. Okay, Newton's law of motion. We are going to actually not, let's see, we're not going to do this one. We'll just do this one. All right, Newton's 3 laws of motion. Drag and drop the correct word of each fill-in-the-blank statement about Newton's 3 laws of motion. The law of blank, objects in motion will tend to stay in motion, and objects at rest will stay at rest unless acted on by a what? The blank, the force, the greater the change in the motion will be. The more massive an object, the less effect a given force will have. And then for 3, for every action, there is an equal and, I just said an equal and something reaction. Okay, so let's think about what the answers would be here. Okay, so let's look at number 1. Law of inertia. It could be law of motion as well, but law of inertia. That objects in motion will tend to stay in motion, and objects at rest will stay at rest unless acted on by a force. The blank, the force, the greater the object in motion will be. The greater the force, the greater the change in motion will be. The more massive an object, the less effect a given force will have. So if it's bigger, the less, if you're pushing a bowling ball or rolling a bowling ball compared to rolling a tennis ball, you're going to need more force to roll the bowling ball compared to rolling the tennis ball. Every action, there is an equal and opposite reaction. All right, so you only have, let's go back to the top to show what you do have. You need to fill in those 4 additional examples. You need to drag the name to the force, so the definition. And you need to answer the question about the boy pushing the box. And you need to answer the question about the guy with the football. Okay, that is it. And you are done with this one. And then the next video, you're going to take a couple notes about energy. Bye.